Okay, let's see if everything's working. Do, do, do. Okay, that should be good. Do, 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 do. Okie dokie dokie. Okay, well, at least I'm streaming, so at least it's something. Check this. Screen. Everything is all good. Now, anywho, we're back to the Wikipedia. Let me move this in this aisle because there's no need. We're not going to talk about investing anymore because that's pretty much my choice. Some reasons has to deal with the developing situation that is pretty historic, which is pretty much winter ice storms occurring around the United States, and talking more about that. Especially with me understanding more about meteorology and how this is occurring, especially with these extreme examples probably occurring um, be this time around the world. Besides that, I think the last thing is with finance, with the article I actually talked about, it really diverted into its own thing, talking about friggin' had its own section about each specific word and how it's not masculine or how it's not related to actual finance. That's the Vox article. Besides that, I think the last article I mentioned, which talks about some words, stated that uh, these are not all the words they have. Matter of fact, Reddit actually, one of the forums has a good list of all the words to actually read and to find a definition about. That the article just gave a general sense of some words, a summary of it, and that's it. So it's not terribly interesting. I think the thing with tendies when it comes to finance, when it comes to shorting and squeezing, is that they could follow under the finance realm when it comes to financial jargon, along with uh, methods people use in finance in general, which I figured I'd just talk about if I ever talk about finance for a very long time, just the topic of finance. But anywho, without being out of the brush, that's why I'm just going to talk about this, because that's something I am interested right now on. Anywho, yeah, you don't see my cursor here. It disappears very closely. Anywho, I might as well get started with Ice Storm. Examples of perspectives in this article deal primarily with the United States and do not represent a worldwide view of the subject. You may improve this article. Yes. Well, I figured just because we're talking about North America, this pretty much says the United States, but let's just go with North America. I figured we'd just talk about it. After all, this is happening mainly in the United States, to be concerned, especially with when it comes to snowy weather in Canada. At least that is something they're able to equip, but not in the country of the United States. So many states don't get snow regularly, and that's the case with many southern states. So that's the thing about this event. So, to further ado, an ice storm is a type of winter storm that characterized by freezing rain, also known as a glace event, or in some parts of the United States, as a silver thaw. The United States National Weather Service defines an ice storm as a storm which results in the accumulation of at least 0.25 through inches, 6.4 millimeters of ice in exposed surfaces from 1982 to 1994. Ice storms were more common than blizzards in the U.S., averaging 16 per year. They are generally not violent storms, but instead are commonly perceived as gentle rains occurring as temperatures just below freezing. Okay. Yo, this is the map showing you what it is. Anywho, contents. 1. Formation. 2. Effect. 3. Notable ice storms. 4. Gallery. And 5 through 7. Just resources. See also references and external links. Well, let's look at the tropical cyclone tracks. Okay, and a 2 1. JPEG. Alrighty. And it doesn't give you an exact date. Oh well. Yeah, this actually shows the cyclones that are going around this area, which is interesting because this is the general area that hurricanes occur. Because hurricanes and tropical cyclones are the same thing, but it's just different names that are characterized. So, yeah. Ice storms can occur under the cyclone because, as they said, right here, gentle rains occurring as temperatures just below freezing. Gotcha. Now let's understand formation. The formation of ice begins with a layer of above freezing. Okay. The formation of ice begins with a layer of above freezing air above a layer of sub-freezing temperatures closer to the surface. Frozen precipitation melts to rain while falling into the warm air layer and then begins to refreeze in the cold layer below. If the precipitate, what a weird word. If the precipitate refreezes while still in the air, it will land on the ground as sleet. Alternatively, the liquid droplets can continue to fall without freezing, passing through the cold air just above the surface. The thin layer of air that cools the rain to a temperature below freezing, 0 Celsius to 32 Fahrenheit. Oh, or 32 Fahrenheit. Yeah, that sounded awkward when I was thinking about it. However, the drops themselves do not freeze, a phenomenon called supercooling or forming a supercold drops. When the supercooled drops strike ground or anything else below 0 Celsius, 32 Fahrenheit, e.g. power lines, tree branches, aircraft, a layer of ice accumulates as the cold water drips off, forming a slowly thickening film of ice and seeing freezing rain. While meteorologists can predict when and where an ice storm will occur, some storms still occur with little or no warning. In the United States, most ice storms are in the northeastern part of the country, but damaging storms have occurred farther south. An ice storm in February 1994 resulted in tremendous ice accumulation as far south as Mississippi and caused reported damage on 9 states. More timber was damaged than the cause by Hurricane Camille. An ice storm in eastern Washington in November 1996 directly followed heavy snowfall. Combined weight of the snow and 25 to 37 millimeters, 0.98 to 1.46 inches of ice caused widespread damage and was considered the most severe ice storm in the Spokane area since 1940. Hurricane Camille. Hurricane Camille was the second most intense tropical cyclone on record to strike in the United States, 1969, around the Texas area. Texas, Florida, around Mississippi, Alabama, Louisiana. Yeah. I didn't know there was a history when it comes to meteorology about these disastrous weathers that happened in the 90s. But it goes to show that there's just not much. And I can actually say just Okay, that was actually good lighting. But yeah, that actually goes to show how, when it comes to history, they don't talk about these natural disasters much. I mean, that could be the same when it comes to many outbreaks, pandemics, and epidemics, diseases. It's something that's hard to romanticize, and it's just a plain old thing that just goes on and hurting something without really just it being natural. Now, I'm going to take some time to understand the formation of it. Graph showing the formation of different kinds of precipitation. I do want to understand more about how this works. Rain. Frozen precipitation melts and reaches the ground as rain. Freezing rain. Frozen precipitation melts in warm air. Rain falls and freezes on cold surfaces. Sleet. Frozen precipitation melts in shallow warm air, then refreezes into sleet before reaching the surface. Snow falls through cold air and reaches the surface. Hmm. So yeah, the warm air coming in, or yeah, the rain coming through. However, the sleet just comes up. There's all this frozen that later rain fall down is just straight sleet versus just snow. So that's how precipitation occurs. Frozen precipitation melts and reaches the ground as rain. Yep, because it's low enough to be warm. However, freezing rain occurs because it's very low because of the warm air close to the ground versus sleet and then snow. Okay, I understand that part now. Which actually works in general on what this occurs. Precipitation in general, but precipitation melts to rain while falling in the warm air there. Okay. However, the drops themselves do not freeze a phenomenon called supercooling or forming supercooling drops. When the supercooling drops strike ground or anything. Let me see what I got. Okay. Just read through the article myself. Yeah, I already just clicked it as well. Supercooling, also known as undercooling, is the process of lowering the temperature of a liquid or a gas below its freezing point without it becoming a solid. It achieves this in the absence of a seed, crystal, or nucleus around which a crystal structure can form. The supercooling of water can be achieved without any special techniques other than the chemical demineralization down to negative 48.3 Celsius, negative 55 Fahrenheit. Droplets of supercooled water often exist in stratus and cumulus clouds. An aircraft flying through such a cloud sees an abrupt crystallization of these droplets, which can result in the formation of ice on the aircraft's wing and blockage of its instruments and probes. Okay, the process of lowering the temperature of a liquid or a gas below its freezing point without it becoming solid. Yep, that is one of the process when it comes to the three stages: gas, solid, liquid, and that's just going to the stage of a liquid to a gas. Oh no! Supercooling is a gas becoming a liquid. All right. So supercooling water, yeah. Yeah, that's pretty much it. There's a lot more about it, but no, we're not gonna go under this. So, yeah, I still can't exit out. I guess I have to. I can do it this way. Oh, now I can pop it. Oh, it's because of this tab. No wonder I'm able to. I close out the tab. Oh, come on, is yeah, good. Yeah, but it talks about super cool and how this occurs. Alrighty. Oh yeah, also, I think in general it's also me just if I want to be comfortable just explaining everything, I have to also explain the background knowledge of everything related to it. Which I don't necessarily know everything meteorology but enough to explain it. I figured just giving some background knowledge is just most acceptable. I shouldn't spend like an entire time just learning about basics of meteorology, then talk about ice storm, because I think it's best for anybody just to jump in and just understanding what's in front of them with some explanation so they can understand it. Um, I mean, that's the amateur part, myself, doing that. When it comes to a fella guy, even though, me doing that, it would be a course, but you know, I don't mind doing a course, but a course, it is something I want to learn in my own way, my own course, versus a traditional course. That's a way how I interpret certain things. Okay, the freezing rain from an ice storm covers everything with heavy, smooth, glazed ice. Glazed ice? Whoa. Glaze or glazed ice, also called glazed frost, is a smooth, transparent, and homogeneous ice coating occurred when freezing rain or drizzle hits a surface. It is similar in appearance to clear ice, which forms from supercooled water droplets. Gotcha. In addition, in addition to hazardous driving or walking conditions, branches or even whole trees may break from the weight of ice. Falling branches can block roads, tear down power and telephone lines, and cause other damage. Even without falling trees and tree branches, the weight of the ice itself can easily snap power lines and also break and bring down power slash utility poles. Even electricity pylons with steel frames. Pylons are pretty much these shaped Eiffel Tower looking things. Transmission tower or power tower is a tall structure, usually a steel. Huh. Oh yeah. Okay. Yeah, the pylons would be here. Yeah, and the shape would just be a tower. Why do I keep on hearing people saying the tower pylon when referring to that? I figured it's just because of these. Yeah. Maybe it's been a while since I actually went outside. Huh. Huh. Because of freaking ice storm, I don't want to break my neck. This can leave people without power for anywhere from several days to a month. According to most meteorologists, just 1/4 of an inch of ice accumulation can add about 500 pounds to 130 kilograms of weight per Line span. Damage from ice storms is easily capable of shutting down entire metropolitan areas. So power lines sagging after an ice storm, besides disrupting transportation, ice storms can disrupt utility by snapping lines and poles. So that's the thing about these ice storms, that a lot of places are losing power. Let's say Texas, because it it is the freezing um of these sleet ice droplets that are adding so much weight to these lines that are not capable of holding so much weight. I mean, even the case with pigeons sleeping on lines is a big issue because that can actually damage it, because a weight of so many pigeons can actually have the lines drop and become weak, or at least weak, which is not good because at any point it actually might just break off and bada boom, bada beam, the power goes off. So yeah, I always figure it's just the trees just falling stuff, but yeah. Or the actual snow itself just being so weighted down by it. I never called the glazed ice that forms around it. Instead of glazed ice are just dropping from the sky. Additionally, the loss of power during ice storms have indirectly caused numerous illnesses and deaths due to unintentionally carbon monoxide CO poisoning. At lower levels, CO poisoning causes symptoms such as nausea, dizziness, fatigue, and headache, but high levels can cause unconsciousness, heart failure, and death. The relatively high incidence of CO poisoning during ice storms occurs due to the use of alternative methods of heating and cooking during prolonged power outages, common after several severe ice storms. Gas generators. Oh, shoot. Gas generators, charcoal and propane barbecues, and kerosene heaters contribute to CO poisoning when they operate in confined locations. CO is produced when appliances burn fuel without enough oxygen present, such as basements and other indoor locations. Loss of electricity during ice storms can indirectly lead to hypothermia and even death from hypothermia. It can also lead to ruptured pipes due to water freezing inside the pipes. Well, let's go with the notable ice storms. November 26th through 29th, 1921. Worst ice storm in known New England history. 4 inches, 10 centimeters of ice hit eastern and central Massachusetts. An ice storm had iced up 6 inches, 15 centimeters thick in northwestern Texas during January 22 through 24th, 1940. In the United Kingdom, a snow and ice event occurred during January 26th through 31st, 1940, as a warm front pushed into cold air. It led to an ice storm south of the Midlands, with some areas being covered up to 300 millimeters, 12 inches of glace by the 31st, with totals still adding up for some areas into early February. Further north, an extreme snow event has taken place. Crippling cities have already had feet of snow covered. Sheffield had 4 feet, 120 centimeters of snow on the first day of the storm alone, with Bolton seeing 10 feet, 300 centimeters high snow drifts from the end of the storm. It is thought that one of the most severe storms to hit the UK. An ice storm had ice up to 6% thick in 6 inches thick in upstate New York during December 29th through 30, 1942. I keep on saying freaking 29, 1929. Wow. Yeah, just 2 events. It sure was troubling while those countries had to worry about a world war a second time. Now, an ice storm which struck northern Idaho January 1961 set a record for thickest record ice accumulation from a single storm in the United States at 8 inches. And that's pretty much it. Wow. So, yeah. So 21. So yeah, 21. Then it occurred around the 40s, and all around 40s. This one time in 61. So one time in the 60s, and then later just in the 90s. Man, so around the 40s, the greatest generation also had to dealt with these storms while during the World War. Anyhow, let's go now to the 90s. In March 1991, a major ice storm in the area of Rochester, New York, caused $375 million in damages, placing it among the worst natural disasters in New York State history. In February 1994, a severe ice storm caused over $1 billion damage in the southern United States, primarily Mississippi, Tennessee, and Alabama. The North American ice storm of 1998 occurred during January 5th through 10th, 1998. It was one of the most devastating and costly ice storms in North American history, and potentially one of the most devastating ice storms in modern history. Reported ice accumulations of 4 inches in some areas. The storm caused massive power failures in several large cities in northeastern North America, the most affected area being eastern Ontario and southern Quebec in Canada, where over 3 million people were without power for up to a month and a half. While trees snapped and electrical pylons were completely flatten under the weight of the accumulated ice. It caused 340 million of damage in May and become one of Canada's costly natural disasters. Yeah, that's a oh, when it comes to natural disasters, that sure was a big thing that people don't know about or can be even forgotten. I mean, you can even say now that when it comes to natural disasters, in the past and this century, so around the 1900s into 2000s, they are focusing on more on natural disasters and how people are becoming more aware, along with other events that are not related to humans directly or so involved. And yeah, one of these things has to do with natural disasters that occurred these past few decades. So that's that. Now, the northeastern United States was impacted by a major ice storm on December 11th through 12th, 2008, which left about 1.25 million homes and businesses without power. Areas impacted with 3/4 to 1 inch, 19 to 25 millimeters of ice accumulation, including eastern New York and the Albany area, central and western Massachusetts, southern New Hampshire, coastal and southern central Maine, Pennsylvania, and the Pocono Mountain regions, northwestern Connecticut, and southern Vermont, southern New Hampshire, and northeastern Massachusetts got hit the worst with the storm with ice accumulation ranging from 1.5 to 3 inches, 38 to 76 millimeters of ice. This left residents unable to get supplies, go to work, etc. Due to blocked roads from trees that fell on the roads, any trees that fell quickly took down power poles. It took utility crews from 4 to as many as 16 days to get a look on the damage and start to restore power to let me stop the wheel because it's making me read a bit slower. Nearly 1.2 million people, and all there were 675,000 residents in New Hampshire without power, and around 375,000 in northern Massachusetts. Yeah, that must be pretty troubling. With this occurred right around from the housing market crash around that time. Well, at least it's bad. Yeah, that's a lot more worse than in the 90s where they probably have to worry about the Y2K bug. But, that only affected a few people who had to handle it versus the entire country and an extent to the world. In late January 2009, ice storms covered several U.S. states, including Arkansas and Connecticut. Most areas affected saw over 2 inches, so 51 millimeters of ice accumulation, and between 1 through 5 inches, 25 through 127 millimeters of snow on top of the ice. The ice storm left well over 2 million people without power at the peak and killed 55 people, 35 in Kentucky. Rural water associations in Arkansas and Kentucky activated an emergency response plan to deal with power loss to small water utilities around their states. Neighboring state ruling water associations, including experienced emergency responders from Louisiana and Florida, loaned equipment and manpower to assist the hardest hit areas. Oh boy, now, let me skim all this. Yeah, you have the gallery, and you have all this. I only have a minute left, but I also have this page as I've been following about here, which I'll get to it next time along with finishing everything. No sense for me rushing, but this is pretty much where I left off around here around the 2009 and 2010. So let me skim through this, and it does look like the last winters that's been occurring was around like the 2008 to 2009, and then last decade after that, in the 90s, was around like, yeah, 90, more like 98, 91, 94, 98. These are more closely together. So who knows? Maybe there's going to be a lot more winter storms and ice storms in the coming decade. Anywho, I'll talk about this next time. So long.